TelecomTV, where ICT connects.
Okay. Hello and welcome again to TelecomTV. My name is Martyn Warwick. I'm reporting this time from the Broadband World Forum event in the Rai in Amsterdam in the Netherlands, and I'm talking with Marc Cohn, who wears two hats. Oh, you can't see any at the moment, but Marc, good to see you. If it's Wednesday, it must be Amsterdam because we were last week together in Germany, but good to see you again.
Good to see you too, Martin.
You are the chair of the Market Education Committee for the Open Network Foundation, and you are also, in your daily bread and butter life, Senior Director, Market Development at Ciena. So, welcome. And we're going to talk about SDN and NFV, but from a slightly different, more overarching proposal. I'd like to begin by asking you this. Look, which came first, the chicken or the egg, SDN or NFV?
Well, if you look at where software-defined networking is originating from, it's with a very dramatically changing landscape that carriers in particular are facing, where demands on the network are growing quite significantly, and revenues per user, or a new metric I heard at the show is revenue per account, is not growing anywhere near in line with those demands. And as a result, something has to change, something has to give, and it's going to be a new network architecture.
Yep.
So I would contend that software-defined networking actually came first as the response to this changing landscape where mobile data and the cloud are actually driving the need to reshape how networking is actually deployed in future networks and services. And at the same time, the implementation efficiencies that software-defined networking entails also is what's going to enable network function virtualization. Now, that being said, NFV also has its roots in terms of economics. The idea at a high level is to be able to apply the server automation value proposition, or in other words, managing servers to managing networks. And this is indicative of the IT and networking convergence that's going on, not just in the carrier environment, but throughout the networking industry as well.
Good answer. I've never heard it spoken like that. Okay, let's move on from there. You mentioned value proposition. What's the value proposition then for SDN and NFV?
I think after listening to operators and speaking to those who are running data centers and private clouds, clearly there's two areas that they're focusing on. One is the concept of agility. Agility means, as one speaker put it this week, faster everything. And they're thinking about time to market, time to new services, and at the same time to provision what they already have. The second area is to focus on the operational side of their frankly, budgets, to be able to achieve OpEx reduction, but not necessarily to ignore Capex reduction as well. It'll just take place under a different set of dynamics. Instead of trying to provide very low-cost commodity hardware, Capex reduction is really about using the existing equipment more efficiently so that you can get more service capacity per network element.
Okay. A lot of talk in the industry is about the programmable intelligent network. Do we have that yet?
Well, software-defined networking exposes that in a similar manner to how mainframes gave way to the PC industry, which changed the world once we were able to decouple the software from the hardware. We're seeing a similar transition with software-defined networking. The real potential is not so much about the details of split control planes and programmable data planes and all that we talk about as technologists, but it's rather this idea of being able to open up the platform and expose a programmatic interface to be able to determine how network behavior is going to benefit a customer or a group of customers in whatever setting that a carrier or a data center operator or so forth is interested in.
Okay. A lot of people always complain, users complain about vendor lock-in. Vendors, frankly, in the past, as you're well aware yourself, are quite happy to have them locked in because it obviously kept things going. With OpenSDN, will that come to an end?
Well, first of all, we would be more than happy in the ideal world to have vendor lock-in on all our customers. No, but realistically, the real question is what's different this time?
Exactly.
And what's different is that end users are driving this initiative. They're driving the need for a new architecture, which has manifested itself in software-defined networking, as well as network functions virtualization, which provides a lot more agility and exposes a means of being less dependent on the physical infrastructure. And when we look at openness, we have to ask, well, what does that really mean? Because different vendors have different contexts. Some believe it's an API. Some believe that it is an open interface to equipment. At Ciena, and I'm going to put my Ciena hat on for a moment, what we believe is there's an expansive openness which really captures all of the above. The idea is that if we are going to support our customers moving forward, then we're going to have to adopt a different model of proprietary technology moving forward. And that means we have to be able to capitalize and offer our value proposition to our customers, but living and residing alongside other vendors who are also going to provide best-of-breed technology and solutions.
Right.
And why is that? Why shouldn't we just take a monopoly? Because our end user customers are actually driving us in that direction. So what our expansive openness concept is really all about is being able to provide the open interface to the equipment to allow us to leverage the control intelligence investments that can be spread over disparate types of equipment, both from Ciena and from other vendors as well. At the same time, we want to be able to support multiple applications and abstract them away from the control intelligence that we've actually implemented within the control layer of our SDN architecture. And then, of course, the final component of expansive openness is being able to offer different types of intelligence, provide a control framework that allows us to run our proprietary, high value added algorithms and software along with others as well. So it has multiple aspects going all throughout the overall architecture.
Thank you. Comprehensive answer. Let's move on finally to the notion of multi-layered optimization. I've been reading what you've been writing about this, and you're talking about the shifting of the economies of service curve that has long been the plague of the operators. So we're talking about multi-layer visibility. How are you going to bring that about, and why are you doing it now?
Well, we've been doing it for a while. I mean, if we look at packet optical integration, that's one element of multi-layer. But the difference now is that when we move to software-defined networking, we actually are also adopting OpenFlow, which is an ONF standard protocol, the first SDN standard, that it is inherently multi-layer. Or in other words, it operates across layers 2 and 3, and to a certain extent layer 4. It has transport port, TCP port numbers as well. The idea is to be able to look at the topology of a network and be able to optimize not just by layer, which is traditionally where we've been constrained in the past architecturally through our OSI model that we've actually adopted for many years, but be able to take advantage of this inherent multi-layer capability of the flows that are providing end-to-end connectivity, optimize the connectivity demands based on the lowest cost or other service-oriented policies that could be implemented. Well, what were some of those policies? Lowest latency, more secure route, highly available route, pass through a particular path or avoid a particular path, or things like lowest energy route, new metrics that are at the application and service layer that are way beyond what we provided before in the physical space. So multi-layer optimization allows us to take advantage of the fact that if we look at the cost per bandwidth at the routing layer versus at the pure optical layer, that we see an order of magnitude distinction, with obviously the lower down the stack, the least cost bandwidth can be made available.
Marc Cohn, fascinating stuff as usual. Great to see you. Thank you very much indeed.
Thank you, Martyn.
TelecomTV, where ICT connects.